All right, everyone. This week we are going to work on quadratic equation problems. The first one we're going to start off with, the first set are the motion problems, are the projectile motion problems. Remember, these are the ones where um, it goes up and then it comes back down. And so there's certain characteristics that you can find from these. They're all the same. They all give you a formula or a function. It's always the same type of function. The numbers are going to be different, but it's always going to be a quadratic. This one, it models the height of the flight of a football as it's kicked into the air. They always tell you what the H stands for. This one is height in feet, and then the T stands for, of course, time. All right. And so there's five things that it can ask for. It can ask for the initial height. It can ask for when and how high it is at its maximum height, which is the vertex. When did the object hit the ground, and how high the object is at a certain time, and when was the object at a certain height. So the same kind of question, just backward. Um, One of the things that we did, we used Polysolve on our calculators. Polysolve will give you the right answer when you plug it in. It'll give you the zeros, which are the when it hits the ground. It'll give you the H and the K, which is the X value of the vertex and the Y value of the vertex. And so it will give you all this information, or you can substitute. If it gives you the time, you can substitute it in for T in your calculator, and it'll get you the answer. Um, but it'll also, one of the other things that we can use is we can use Desmos. All right, Desmos will give us the graph. We can plug it in, and when we plug it in, it'll give us the picture of the graph, and then we can just look at it. We can use our tracer, trace our mouse over top of the part, and be able to do the problem. So here we have a picture of what the graph looks like. All right. In black are the questions. In blue are how you do it. Then it tells you how to do each one. So you can see some of the questions again here. What is the initial height of the object? It's always the y-intercept. So before going any further, remember the y-axis is always the height. All right. The y-axis is always the height, and the x-axis is always the time. All right. So when it's asking for how high something is, you're always looking at the numbers over here on the left. If it asks when or what time, you're always looking down here at the numbers on the x-axis. Right. They all have the relationship together. So um, so remember that. So here are some of the questions. What's the height? What's the initial starting height? Again, so here's height. What is that? And so when you're doing Desmos, you can take your tracer, your mouse, and you can click on that, and it'll give you the point. It'll give you remember, you're looking for the Y value. It's going to give you an X and a Y, but you're looking for the Y value. If it asks for the maximum height, or how high it goes, or when it got to a maximum height. Again, there's your vertex. There's the highest point. So you've got 2 points here. You got the x value is the time, and you got the y value is the height. Right. So that 1 point answers both questions. All right. Um, Down here it says when will it hit the ground? All right. Well, that's the furthest right x-intercept. So right here is the ground. All right. Since it asks when, we're looking for the x value of that point. All right. Um, these two questions here are kind of the same thing, just opposite. It says if it asks when it's at 20 feet, all right, you can go over here to 20, and it's actually two times it's at 20 feet. All right. So two times here, you would go down and you would look and see what is this x value and what is this x value. All right. Again, when you trace your mouse over, it's going to give you the x and the y value. All right. The other question, it says how high it is at a certain time. All right. So one of the things, before we go any further, we go to the next slide. When you do Desmos, make sure you plug in it for x instead of t. right? It'll be x squared and x instead of t squared because Desmos looks at it that way. So here's that same question we started off with. All right, the function there's the football. All right, it models the height. H represents height in feet. T represents time in seconds. All right. So what I would do is I would go and I would plug it into Desmos, and Desmos would give me this picture here. All right. Again, I kind of just screen saved all the points, but you could just take your mouse and you can drag it over the graph, and it'll stop and give you an x and a y value for each point. All right. So remember that the y value is always height, and the x value is always time. All right. So the first question says, what? How high was the football when it was kicked? All right. So we would look at our Desmos. All right, and our height right here. All right, when it was kicked. So you can see that at time is 0 because that's when we kicked it. The 0 seconds. The height was 2.5 feet. All right, so we go back up here and we say 2.5 feet. All right. The next question it says, what was the highest? What was the highest the football flew? So again, it's asking about a height. So we would go back to our graph. All right, and we can see that the highest it flew was the vertex. Now it said what was the highest, so that's the y value of the vertex. All right, that's not asking for a time yet, it's asking for how high it was. So we go back, and that's what, 58.75. So we go back and we write down 58.75 feet. Remember, when we do word problems, we always write down the units. All right. And then number 3, it says, how long did it take for it to reach its highest point? So now it's asking for when. All right, quickly go back and look. The when is the x value. All right, the when is the x value. So it took 1.875 seconds. All right. Then we go to the next question. How long before the football landed on the ground? All right. So we just go back and look at our graph. The ground is the x-axis. And again, it said how long. So again, that's time. So I'm looking at the x value of that point. All right. The ground is 0 feet high. So that's why the y value is 0. So it hit the ground in 3.791 seconds. All right. So you go back to your page. Oops, sorry about that. 3.791 seconds. Notice it asks for time, that's always the x value. As for height, that's always the y value. So when you look at this problem, number 5, how long was it? 3 seconds. So I'm going to go back and we'll look at the graph at 3 seconds. All right, 1, 2, 3 is over here. All right, and right there, that point right there. All right, kind of covered up with, but it looks like 38.5 feet is how long it was after 3 seconds. So we go back and we say 38.5 feet. All right. So when we're doing that last question, it says to the nearest second, how long did it take to go 47 feet? All right. So we go back 47 feet. So this one actually is it said 47 feet. So we're looking over here at 47. Again, you would just trace your mouse over top of the graph, and it'll, on Desmos, it will give you the points. So 47, that's the closest we could get here. And actually, I skipped one, I missed one. 47 would be over here as well. So to the nearest second, we would say 1 second here, and this one here looks like the nearest second would be 3. So at 1 and 3 seconds, it's at 47 feet. All right, so we go back and just say at 1 and 3 seconds. And that's the gist of it. So if you want to do Desmos, that's the easiest way. If you still want to do polysolve and get the zeros and substitute and get the H and the K, that is fine too. I looked for a way to do it on a to show you how to do polysolve again on the computer, but there's no easy way to do it. So if you want to look it up, you're fine. Or if you want to just use your Desmos, either way, you're fine. And good luck.